Today's notes are on solving algebraic equations and solution sets. So to start these notes, we're going to write a definition of what is an algebraic equation. We've discussed this in class, so we're just going to formalize it so you have it in your notes. An algebraic equation is a statement of equality between two different expressions. And an algebraic equation can either be always, sometimes, or never true. So we're going to look at, and I'm going to write in an example for each about where is the algebraic equation always true. So it's always true if we're using one of our properties like distributive property, associative property, or commutative property. So it could be something like 2 times x plus 3. Well, if I apply distributive property there, I get 2x plus 6. These two expressions will be true, or will be equal, no matter what value I plug in for x. I could plug in 1, I could plug in 100, I could plug in 0.5. It doesn't matter. This will always be true. Okay? Sometimes true, that's where there's only certain values of x, or of the variable, that would make the equation true. So that's something like x plus 3 equals 5. Right? This is true when x equals 2. Okay? And then lastly, we'll look at when would an equation never be true. And that would be something that is, there's no value of x I could plug in that would make the equation true. And my example is going to be x equals x plus 1. Right? There is no possible value of x that is also equal to 1 more than itself. Okay? So now we're going to look at an example where we start thinking about what values will make this equation true and what does it mean to be a solution set to an equation. So if we look at the equation 7 plus p is equal to 12, now you might know off the top of your head what value of p would make this equation true, but certainly we could test out other values. So we could say let p, if we look at the table, let p equals 0, then the number sentence would be 7 plus, I'm plugging in 0 for p, so where the p was I'm writing 0, is equal to 12. Now, when I go to the truth value, I'm deciding does 7 plus 0 equal 12? No. So for my truth value, I'm writing false. And we can do the same thing for when p is 4. I would have 7 plus 4 equals 12. Well, 7 plus 4 is 11, not 12, so this again is false. Then the last example here, we can try 5, and we get 7 plus 5 equals 12, and that one ends up being true. Okay, so now you might have known that from the beginning, so I'm just trying to show you here that we can try other values, and we're going to get something false. Okay, and this kind of leads into our definition of a solution set. A solution set of an equation with one variable, because that's all we're focusing on right now, is the set of values, or we'll say the set of all values that make the equation true. And we call these values, the values are called the solutions to the equation. So coming back to our example, 7 plus p is equal to 12, well, we found the solution to be 5 because 5 was the value of p that made the equation true. So I could express this in words by saying the solution is p equals 5. So that's one way I could express my solution. Another way would be graphical representation. So we can do that on a number line, and I can kind of label my numbers. I'm going to put 0. I know I need to get to 5. 1, 2, 3, 4, 5. And the way I'm going to show the solution on a number line or in a graphical representation would be just to put a circle, put a little dot on the number that is the solution. Lastly, I'm going to show you how we would do this in set notation. Set notation might be something new for you, and the way it works is you use these little, what are called curly brackets. They look kind of like this. They're similar to parentheses. And then inside of the curly brackets, you would list out all of the solutions. Now, in this case, we only have one solution, so I'm just writing a 5 inside of curly brackets. In this next example, we're trying to solve for a in the equation a squared is equal to 25. So we're trying to think about what number, when I square it or multiply it by itself, do I get 25. Now, you may have already realized one solution right away, which is 5. But there's actually a second solution because negative 5 squared is also equal to positive 25, because when I square the negative, I multiply negative 5 times negative 5, which is positive 25. So both 5 and negative 5 give me solutions. So when I express this in words, I'm going to just say the solution is (5) and negative 5. When I express this in set notation, I'm going to use my curly brackets. So it looks like this. And inside, I need to list both of my solutions. And I'm going to do it from the smallest to the largest. So that means I should put the negative 5 first, comma, 5. Now this doesn't mean an ordered pair. It's not x comma y. Because it's in curly brackets, it means the set of the solutions, which is negative 5 and 5. Okay? Graphically, we could draw a number line. I'm going to put 0 in the middle this time because I know I need to get to both negative 5 and positive 5. I'm not really writing out every single number in between, but that's okay. This is more just for a visual. And then I'm going to mark a dot on 5 and a point on negative 5. Okay? Now, since set notation is kind of new, I created this little box for you guys on the right-hand side of your page to kind of give you some pointers as what are we doing or what are you thinking about when you're using set notation. Okay, so the first thing we're going to kind of put in here is we're using those curly brackets. And if you're having a hard time drawing them, one thing I do is kind of draw like a little S with like very short little ends, and then I do the same thing again upside down. Oh, I failed that time. So I do the same thing again, and I get kind of like those two shapes. Okay, so those are our curly brackets. The next thing is we call the solutions the elements of the set. So we can say the solutions, and this is just like our vocabulary of sets, are the elements of the set. Okay. The third thing I want to make sure you understand is we're writing the elements or the solutions from least to greatest. So we list elements from least to greatest. And the last thing to note here is if there are no solutions, we could have an empty set, which means you just draw your curly brackets and you don't put anything inside. Okay? Another option there would be you could also, instead of drawing the curly brackets with nothing inside, you could draw a 0 with a line through it, and that would mean the same thing. So now what I'd like you guys to do is, before moving on to the next part of the video, pause the video and try the you try example here, which is x plus 6 equals 10. Okay, so the idea is you should be able to easily get a solution, and then you're going to write it in three ways. You're going to write the solution in words, in set notation, and then also show the solution on the number line. Okay, I have one last example for you guys, and this is the equation x divided by x equals 1. So this equation looks a little bit different than some of the other ones. It's not something you can look at and know the solution maybe right away, but certainly we could test out certain values and see what happens and see if they make the equation true. So if we look at this table, we're going to first let x equals 2, which means we plug in 2 for x. We get 2 over 2 equals 1. So is 2 divided by itself equal to 1? And yes, 2 divided by 2 is equal to 1, so this would be true. Now let's think about negative 7. Negative 7 divided by negative 7, does that equal 1? Well, yeah, the negatives cancel out, so you have negative 7 over itself is 1. What about a decimal like 0.01 divided by 0.01? Does that equal 1? Yes, it does. Now let's look at 0. If I do 0 divided by 0, now this actually, we run into a problem here because we cannot divide by 0. So 0 divided by 0 is actually undefined. So that means it is false, okay? So hopefully from this table, we start to see a pattern, which is if we plug in any number, positive or negative, into this equation, it should make the equation true unless that number is 0, okay? So to describe our solution set, we can say the solutions are all real numbers except 0. And when we go to write that in set notation, it's a little bit different than if we're just listing solutions because there's so many solutions. So we can just say x is real, and we're going to put like a little line, and we're going to say our one restriction, which is that x cannot equal 0. And that would be my set notation. Graphically, on a number line, the idea would be we want to highlight everything except for 0. So I'm going to put an open circle at 0, which means I don't want to include it, but then I'm going to shade in both directions to represent that anything else along this number line could be a solution. So if you are confused on any of this, we will be practicing tomorrow in class, and you'll be able to ask any questions you may have.